This video will cover 126 variables and functions. The person who is coding with Robot C should have the Project Lead the website on their computer because you'll be copying and pasting the code from there. So from this website, make sure you click on the PLTW engineering folder and then the computer integrated manufacturing. Scroll down a bit and you'll find unit 1. Click on that. And then on the left side, you're going to see Robot C, lesson 1.2 control systems. So click on that one. So the video is going to cover the parts 1, steps 9 and 10, part 2, and part 3. So if you scroll down, we can skip the initial steps. Actually, we need to go to 1.26, so variables and functions. And then you scroll down and skip the few steps all the way to 4. Okay. So I'm going to go back to my Robot C and let's open up a new part. I'm going to close all of these and start from the beginning. So what you want to do is open the file from the last one you worked on, which is A125 part 3. And then we're going to go to File, Save As. You'll notice my code here is different because I actually messed up and saved over it. So ignore the code that I have here. We're just going to delete that and put something else later. So 126 and then part 1. I want to put step 9 because there's 2 steps for part 1. So just so we can differentiate from between those two. So click on Save. And let's go ahead and delete these codes. Let's delete the pseudocode. Make sure you do not delete this one. The task description, we can delete that also. We can change the date. And let's change this one right here. So variables and functions. This is A126, part 1, step 9. All right. Let's go back to the Project Lead the Way website, PLTW. And what we're going to do here, we're going to use a function or a variable. And it allows the computer or the robot to count how many times it does a certain program, certain code. So if you look at number 6 here, the motor count will start at 0. So there's a function or a variable that we define, right? Motor count. So that's something that we will define later on, or something that the robot has to refer to. So before the code starts, the motor count starts at 0. And so the actual code is actually here under this while loop. But the while on the while loop right here, in this condition, if the motor count is less than 3, then this code will occur. Okay. So since we're starting with 0, obviously the motor count is less than 3. So the right motor will start, wait 2 seconds, then it will stop and wait 2 seconds, and then the motor count will get a +1. So as it goes back up here, the motor count will become 1. So the computer is doing this internally, or the robot is doing this internally. You will not see a 1 there later when you press start. But internally, the robot is actually counting. So since this is a 1, the motor count is less than 3, then it will repeat this code again. This code, then it will do another count. It will add a +1, so the motor count will become 2. And it will repeat because it's less than 3, so go over the whole process again, and they'll add a +1. The motor count will be 3 now. And so, since the motor count is not less than 3, and the code will stop. Okay, so that's the idea here. So instead of you putting start motor, stop motor 3 separate times, you have a motor count. And if you want to add uh, more repeats, then all you have to do is change this number 3 to a higher number. Okay. So so for this one, what you want to do is copy this, go back to your code, and paste it. Okay, we're gonna click on fix formatting. Okay, task description. Um, we're gonna do a define a function, uh, define a term. Okay, uh, use a variable. I'm sorry, define a term, or we'll call it variable. So that the word motor count is a variable. So define a variable and use that variable to repeat. Okay. All right. Pseudocode. Um, define variable. Start count at 0. Start motor for 2 seconds. Stop motor for 2 seconds. Add 1 to the variable. If less than 3, repeat. Okay. That's what's going to happen. As long as the motor count is less than 3, which is 0, 1, and 2, then this code will occur. So pause this video and give this a try and see how it works. And then on step 9, your work will be checked. All right. Okay, let's go to step 9. Document this program. What this program will look like for simple behaviors. Oh, actually, we just did that. So step 9 is actually this. It's right here. Okay. So we define the variable, start the count at 0, and start motor for 2 seconds. So when I check your work, make sure you're able to explain what is happening on this code. So that is step 9. Okay, and there's nothing else. All right, so now let's go to step 10. So let's go to File, Save As. We'll just change this to step 10. Click Save. Okay. Create a program that will run the motor back and forth 20 times, 0.5 seconds each way. Test the program, troubleshoot until expected behavior has occurred. Okay, so this will become our task description. I'm going to copy that. I'm going to paste it here. So instead of every 2 seconds, it's a 0.5 seconds each way. So we still have a motor count, but we want to do 20 times. So we're going to put here 20. Okay. We're not going to put 21 because you're also going to count 0. So technically on the 19th time, 0 is the 20th time. Okay. So we just put a 20 there. Then the start motor, it doesn't say what the speed is, so we'll just leave it at that. But this time it's 0.5 seconds. And that's it. Compile it and see if there's any errors. Save it. Okay, and then download to robot. All right, I'm gonna check it here and run this program with you on this video to make sure that it actually works. So this is gonna happen as long as the motor count is less than 20. So if I use a debugger window, I might be able to get something. Um, Sensors. I'm trying to put my debugger window here so that you guys can see it. I just remembered I did remove my sensors. Okay, so for you, you shouldn't have to mess with this at all. But my sensors now are here. Okay. Um, yeah, I don't think I have like the count. So I'm sure there's a way to do the count, but I think we're just gonna skip that for now. Okay. All right. So now let's move on to part two, step 20. So for step 10, this is what you have to show with all these changes. Obviously, you have to have your comments here before it gets checked, and then now you can move to step 20. So let's do part two now. Okay, so for part two, this is another form of a variable or function. You define the function or the variable, and then you use that to create a code. Okay, so for part two, we're doing step 20. So we're gonna use this, and then there will be a few changes you have to make uh, through this step. And then we're gonna do step 20. I think we're gonna do the first one, okay? But you don't have to save it to a different file. So what you want to do is, let's go back here, close this. Oops, I just have to open that again. So open file. Okay, all right, so it's saved. We're gonna go to file, save as, and then we're gonna do step part two. We can delete the step 10 here, okay? Because there's only one part two, and click save. Okay. In this one, we're gonna. This is part two. Delete the step 9. I actually forgot to delete the change the step 9 to 10, so make sure you change that if you have a chance. All right. Create a program that will run a motor back and forth 20 times, 0, 4, 5, 6, and 3. Okay. So for this one, um, we're gonna have okay. All right. For this one, robot C will record the closest value measured. Okay, so you'll kind of understand that later on as we code this. So define variable. Um, let's see. At start, uh, record the closest measurement. Okay. Uh, Press limit switch. to reset the recorded value. Okay. All right. We're gonna delete this, all of this inside the curly brackets. We're gonna copy this. I'm gonna explain this what this is on this video. All right. We're going to compile it, fix formatting, and then save it. Okay. All right. So for this one, we define a we stated a term. The term is biggest. It will start at 0. One is greater than 1 is equal to 1. The biggest value is 0. But while the bump switch is 0, we want the sensor value uh, that is larger than 0, which is in this case biggest, to be recorded. Okay, so it's a little bit confusing. But once I show you guys it's on Robot C, it'll make more sense. So you'll notice when you click start, this is going to be true, because when the bump switch here, if you look at the picture on the right side, this one right here, if it's not pressed down, it's actually 0. So what it's gonna do is gonna record that biggest value, okay, whatever that value is, okay. And so let's give it a try. But before we do that, we have to make some changes on our screen. So we have to go to View, Preferences, Compiler. So back to your Robot C, gotta go to View, Preferences, and then down here, Compiler, or is it Detail? Actually, Detailed. So the PLTW is not up to date. So go to Detail Preferences. You're gonna go to Compiler, right here. Click on that, and then you're gonna go to Code Generation. You want this to be on Force Classic. So I'm already on Force Classic from before. So you want to be on Force Classic, apply it, and then OK. All right. So I'm going to compile. I'm going to download to Robot. All right. I do have a couple of things going on. My motors, but I do want my sensors to be out here, but it's not showing up. Okay, so I need to go to Robot, Debugger Windows, Sensors. Okay, it's not on the same one. So for some reason, I'm trying to put this with the rest of this window here. So there has to be a way. Oh, there you go. Okay. All right. So yours is going to look something like this. Your sensors and motors are on the same window, and then we do have to get another one. We have to get global variables. So we have to go to Robot, Debugger Windows, Global Variables. Again, mine is set up that way because I was using this earlier. So I'm trying to set it up the same way as you would see it. But now mine is not here. So global variables is somewhere here. There you go. See, it's hidden in the back. Okay, so now mine is set up almost the same as yours. Okay, so I had to make those changes. All right. So what you want to do is this: you need to take global variables and bring it out like that. Okay, it's going to be a separate window. It might be smaller than mine, or it might be the window might be bigger, but just adjust it. And then the sensor is going to do the same thing. You're going to take that out, make the window smaller, just so that you can see the values. Okay. All right. So once this is out, you'll notice um, we're looking at the potentiometer, right? Okay. So if I look at my potentiometer is right here, and I look at the value right here, if I press start, it's going to record the biggest value it has recorded, it's seen. Okay. Once I move my, so right now the value is 1450. But if I move my potentiometer, okay, it's going to record the biggest value that is being recorded or it's being measured. Right now it's 2385. Okay. So this is perfect if you want to be exact or what value, which is the biggest value that you've measured. Okay. Now, if I turn the potentiometer the other way, it's not going to record anything because everything is lower than the biggest value. Okay. So it will only record, according to my code right here, it will only record if the potentiometer reads the biggest value. Okay. Now, what if I want to reset this? Well, I just click on the bump switch and then it records now the biggest value that it's reading. Okay. So I can turn it. Okay. I can go back, but the value will remain the same because it's lower. But if I turn it to pass that initial value, then it will record that biggest value. So anyway, we can do the same thing for like the sonar and the light sensor. So for this assignment, it will be the sonar. Um, so I'm going to put it on the sonar. I'm going to put that on the pseudocode. Okay. So what we want to do for step 20, if you have the ultrasonic distance sensor, modify the program so that the variable closest. So that we're going to change the variable closest. And all right, so just follow what I do here and just do it on your screen also. So the variable is closest. We're going to change that. All the one that says biggest, we'll change it to closest. Okay. Now, instead of using a bump switch, it does say that we have to use a limit switch. So let's change that to limit switch. And that's it. And then this one, the potentiometer, will be sonar. Okay. Now, obviously, closest cannot be zero. That means it's next to the object, the sonar. So we're gonna, since our ceiling is kind of high, we're gonna say it's 100 inches, maybe more. So we'll put 200 inches. Okay, that's the closest value we'll start with. But obviously, it's gonna read whatever your ceiling is, how far your ceiling is to the sonar. Okay. All right. So what we're gonna do now is this. We're gonna stop this. We're gonna save it or compile it, and then save it. Um, I believe that's supposed to be closest. Let's try that. It's telling me to change that to that, but I'm not quite sure. Okay, download that to Robot. Let's see if this will work. All right. So if I press start, the reading right now is 200. The closest reading is 200. If I put my hand, so this is the sonar right here. If I put my hand over it, it should read something, right? So you can see the value is not changing, right? Um, and so it only reads when the value of the sonar is greater than the closest. So the closest is 200. When I put my hand over it, it's not greater than 200. So we have to change the symbol right here to less than. If it's less than 200, less than the closest measurement, then it will record that. And remember, we're starting with 200. Okay, so we have to beat that 200 mark. Okay, so I'm gonna press stop, close this, and then download again. So save it, and then download. So we're gonna start with 200. I'm gonna press start. It's actually 89 because that's how far the ceiling is. So if I put my hand over it, notice the value now is 10 because it's 10 inches away. If I bring my hand down, it's 9, 8, 7. But if I bring my hand up, it stays at 7 because I'm not getting any closer than 7. Okay? So my hand is greater than 7. If I bring it down, you will go to 6, 5, 4. But if I bring it up, it doesn't change. Now, how do we reset that? Guess what? We just have to press the limit switch. Okay? And now it's reading the ceiling, and that's closer than 200. Okay? So that's how it works. This is great for if you want to record a certain value because the values does jump around. Okay? All right. So I'm going to press stop. This is what you need to show your teacher to get full credit for this assignment. Actually, um, let's see. Now, I'm not quite sure if we need to bring this back. So before you actually close this, so click on download to robot again, and then let's put this back um, with the group right here. So I think you drag this and you drag it here, and you're looking for this middle icon. So it puts it back with the rest. So drag it, not here, but over here. You get to see this looking for this middle icon. That's where you want it, and then you can close it. Okay, we're gonna save that. All right, now let's do the last one. So go to File, Save As. This is part 3. Okay. All right, so part 3. Okay. So in this one, we're just gonna copy this, and all you have to do is describe what is happening. That's all. So again, on this one, you have a function. You declare a function. It's called LED control, and you can use that LED control anytime in your code, and you don't have to write that specific code over and over again. So what it does is this: you have a code, like a word or a term. You define it by this. So LED control means that if you press the bump switch, the LED will turn on. If you don't press it, it will turn off. So it's a simple code, but later on, if you need this code later, all you have to type in is LED control. Okay. Um, so this is the function, the name of the function, and this whole thing defines that function. So void LED control. What is it about? Well, it's this. If you press the bump switch, LED turns on or off. Okay. All right. So we're gonna copy that, and we're gonna paste it here. Okay. Task description. Uh, use a function uh, to control an LED. Uh, define function as bump switch, and LED will turn off. Release the bump switch, and LED will turn off. Actually, this is supposed to be on. Okay. Pilot. Oops. Let's see. Fix formatting. Oh, this is where I made a mistake. Okay. For this one, it's a special circumstance that where you have to put this void LED control before the task main. Okay, so that's where my mistake was. So since we have the task main here already, what we'll do is I'm going to delete that, including the curly bracket, and I'm going to delete the last curly bracket here. I'm going to go to fix formatting again, and then compile it, and now it's correct. So we click save. So the only thing is that you have to put the function before the task main. Okay. All right. Sending download to robot. And it's a simple code, but there's a function that's connected to this. You press start. When you press the bump switch, LED will turn on like here on the video, and like go on. And it keeps going forever because the while is 1 equals to 1. Okay. And that's it. That's how functions work, and they're very useful when you're writing a very long code. Okay. All right, and that's it. And thank you. Good luck.